So in this video, we will talk about the shell method. So let's say we have just like a graph, right? Let's call this y equals x times x minus 1 squared or something like that. And we're trying to find the volume using the shell method. So in this situation, we would have to just do one simple thing. We have to find, we have to put the rectangle, we have to put like a rectangle inside the thing the region your function is in. So like in this situation, if this is about the x-axis, you would, I'm sorry, if this was about the y-axis, you would have to put it in terms of y. So as the direction as y is going through, so it's going down vertical, right? So we have to put it in terms of the y-axis. So let's make it vertical. Let's make it parallel to the y-axis. So we have a height. Let's call this h. We have a thickness. Let's call this delta x. And we call this delta x because perpendicular to the x-axis, that means it's the thickness is delta x. And yeah, that's pretty much it. And we have to put our radius from the y-axis. Since it's about the y-axis, we have to it starts from the y-axis and it leads up to that rectangle you just sketched. So that's pretty much all you need to know. So these are the three things that you need to know: the radius, the height, and the thickness of the function. These three things are really what all you need to know in order to find the shell method. And the equation for finding the shell method is just this. V, or volume, equals 2 pi from the endpoints from A to B, the radius times the height, and the thickness. It could be delta x or delta y, but in reality, it's just dx or dy, or depending on what it's asking. So this equation is what you need to know. So let's look at this question. So it says, let S be the solid obtained by rotating the region shown in the figure about the y-axis. Explain why it's awkward to use the Washer method to find volume V of S. Sketch a typical approximating shell. What are its circumferences height? Use shell to find V. Okay, so let's just get down to business and let's just forget about explain why it's awkward to find the Washer method or to use the Washer method. And let's just find the answer because I think that's what all you really want to find out, just to know how to do this concept. So I'm gonna explain it to you. So they given us a function, right? Like as I showed you earlier, right? And let's find the region or the volume about the y-axis. So first we have to sketch it again, right? Let's sketch this again. It doesn't have to be perfect. So this is the function that they're giving us, and it says about the y-axis. So that means we have to draw a little rectangle right here. And yeah, since it's parallel to the y-axis, it's going in the same direction, the y-axis, we had to draw that rectangle in a vertical way. So here we have our height, here we have our thickness. This is delta x, and from the y-axis to the rectangle, this is our radius. This is our radius. So as you can see here, our radius is going to be just x, because if it's going in the same direction as the x-axis, since the x-axis is just straight towards the right, as you can see, and the radius is going towards the right from the y-axis to the rectangle, so it's going from left to right. And at this point, it doesn't matter what it's going or where it's going. It just knows that it's in terms of x, because it's going in terms of the x-axis in the x-axis direction. So radius will be equal to x. And the height, this will be the function you are given with at the beginning. So right here. So the function or the height is going to be x times x minus 1 squared. And the thickness, from what we've seen or what I just sketched, is going to be delta x. And now we have all our components to solve this problem. So let's do our problem right here. V equals 2 pi from 0 to 1 because they're giving this to us. And let's put our radius here. Let's put our height here too. X minus 1 squared. Put our thickness dx or delta x, the same thing. And yeah, let's try to multiply this. So x minus 1 times x minus 1, we have to distribute. So this will be equal to negative 2x plus 1 times x times x. So x squared minus 2x plus 1 times x times x. That will be equal to x4 minus 2x 3 plus x squared. So now let's integrate this. So let me make more room here. So x to the power 4 minus 2x third to the power 3 plus x squared. Let's integrate this very easy. x5 over 5 minus 2x to the power 4 divided by 4 plus x to the power 3 over 3 from 0 to 1. Now let's plug in our values here. So plug in 1 for x. So we can cancel the 2 and make it a half because 2 divided by 4 is 1/2. So we'll plug in the 1 plus 1. Oh, 1 to the power 3. We get to minus 0. This will be equal to 0 since if we put 0 to all the values, it will be just 0. So and let's try to make these in terms of the same denominators. So let's start with 1/5 minus 1 squared, or 1 over 2, my bad. So the same denominators for those two would be 10. So 1 over 5 times 2 would be 10. 1 over half, 1 over 2 will be times 5. So because, yeah, and this would be equal to negative 3 over 10. Still got the 1/3, so we gotta make this in terms of, let's try 30. So negative 3 times 3 is negative 9. 10 times 3 is 30. 1 times 10 is 10. 3 times 10 is 30. This will be equal to 1 over 30. And remember guys, we still are not finished because we still have the 2 pi times 2 pi. 1 over 30 times 2 pi. 2 pi over 30. We can simplify this further, and this would be pi over 15 cube unit. And this is our final answer for this question. So let's look at this question. It says use the method of cylindrical shells to find the volume of the solid obtained by rotating the region bounded by the given curves about the x-axis. So here we have to kind of tweak this out a little bit. So because it says x times y equals 1, we are going to have to find the function in terms of one x or y value. So since it says about the x-axis, we have to find it in terms of y. So let's divide y. So we just get x. So x will be equal to 1 over y. And we have our x function we have our lines, or x equals x values and a y value. Now we have to graph this thing. Let me do a t-chart and let me try to finish this up or try to find the values. So I have my t chart finished and now I'm going to graph it. So 1 is equal or match with 1/2, match with 2, and 1/3 is match with 3. So it'll be going up like this. And so now it's time to put in our specified lines. So x equals 0. So x will be equal to 0 here. Y equals 1. Let's make a vertical or horizontal line, my bad. Horizontal line. So this will be y equals 1. Doesn't have to be perfect. Y equals 3. Y equals 3. And as you can see here, we are going to find this shaded region, of the volume. So try to find the volume of this region, of the rotating region, bounded by the curve about the x-axis. So what we gotta do now is find our radius and height and thickness. So this is really simple. So now we have to make a rectangle, but since it tells us we have to find it in terms of the x-axis, we we have to make a rectangle by the x-axis. So what does that mean? We have to do the rectangle, but in this position because it's in the direction of the x-axis. So this is parallel to the x-axis direction, and yeah. So a radius would be from the x-axis to the little rectangle. So this is our radius right here, and this is our thickness. This is delta y because the y-axis is in terms of delta y, as you can see here, because it's in the same direction as the y-axis. And this is our height right here. So our height would be 1 over y. Our radius would be just y because it's going in the direction of the x-axis. Yeah, no, not the x-axis, because it's going in the direction of y. Since it's going down, the y-axis is vertical, and this is vertical as well. So this is in terms of y. The thickness is going to be delta y. And now we have all we need to do our equation. Let me just get this out of the way to make more room. So I know this is kind of messy, guys, but trust me, it's gonna be worth it. So let's try to find our problem or our solution. And let's put in our equation, v equals 2 pi from 1 to 3, because y equals 1, y equals 3. And this is in terms of y. So, and our radius is y times the height, 1 over y, dy. So y times 1 over y is going to be, it's going to be 1. And when we integrate that, that will be y. Now we have to put in our values. So 3 minus 1 would be equal to 2. And remember, we have to put our 2 pi because we still have 2 pi we have to left to use, and that would be equal to 4 pi. So our final answer would be 4 pi cubed units. And that's the final answer.